Hello, listeners, and welcome to the fifth and last program in our series, Let's Learn Life Science, which is produced for grade 9 learners and anybody else who has an interest in the subject. My name is Jandre, and today we'll learn about the scientific process. I am joined in the studio by Bernard and Laya. Please have a pen and notebook ready so that you can make notes of the important points. After listening to this program, you should be able to calculate magnification, estimate or measure volume, length, mass, time, or rate and temperature. Convert units of volume, length, mass, and temperature. When newly wedded couples have their photos taken during and after the wedding ceremony, the photographer has to zoom in on their rings during the exchange of rings because the details of the rings must be captured. Many couples often enlarge that specific photo and frame it and display it in their houses. We make things bigger with our phones every day. Take the selfies we take every day as one example. We use the zoom function to make them bigger or smaller. This is the principle of magnification.
You're right. I once ordered a bag I saw in a catalog, but I didn't check the size and all the measurements. When I received it 2 weeks later, I was unhappy because it was much smaller than I anticipated. I think the picture I saw was an enlarged image of the bag.
Pictures never display accurate sizes. That's why you should always look out for the measurements of the object given in the picture.
My mom loves doing embroidery and always uses a magnifying lens when she works. It takes the strain off her eyes having to look at the small stitches for a long time. The hand lens enlarges the area she is working on at the time. School laboratories also have hand lenses, and they are always marked with their magnifying power. For example, 8 times or 10 times. That means the image that one will look at through the hand lens will be enlarged as many times as indicated on the lens compared to the real object size. That's why you have to state the magnification when you are making a drawing of a small object in life science. That means you must say how many times bigger than the real object you're drawing is.
It is very easy to determine the magnification of your drawing, and that's the beauty and usefulness of the magnification formula. The formula for calculating magnification is equal to the size of the drawing divided by the size of the actual object.
Let's use a worm as an example. If your drawing is 110 millimeters long and the real worm size is 75 millimeters long, the magnification will be 1.5 times because 110 divided by 75 equals 1.5. That means when I insert the actual numerical values in the formula, namely magnification equals 110 millimeters divided by 75 millimeters, so magnification would be equal to times 1.5. The answer must be rounded off because the actual answer when dividing is 1.466666. It must be rounded off to 1 decimal place and the magnification must be written next to your drawing. You must also not forget the times sign next to the magnification.
We will be moving on to estimations now. When you estimate something, you make an intelligent guess about how heavy, big, hot, cold, large, or small it is.
Indeed, an estimate is a rough calculation of value, number, quantity, measurements, or extent of something. For example, a scientist is recording the mass of a type of seed. After a while, she realizes that most of the seeds have a certain mass. The next time she sees the specific type of seeds, she will be able to estimate its mass.
I also have a nice example. Just by looking at a pair of shoes, I'm able to tell what shoe size it is. I've observed shoes long enough to an extent that I can now estimate their sizes.
That's a nice one. Let me give one last example. Think of your height as indicated on your Namibian identity card. How accurate is it? If you don't have one yet, you will soon apply for one.
It is important to record your data neatly and accurately. If you don't do that, the data may not be of use to you or someone else.
Imagine getting wrong marks in a test, or imagine getting wrong blood pressure readings or even temperature. Instead of 35.9 degrees Celsius, you get 39.5. I'm sure you'd be very worried about such a high temperature reading. Therefore, we need to be extra vigilant when recording data.
The best way to record data is in a table. All tables must have columns and rows, and each column or row must have a clear heading. We can also use Microsoft spreadsheet programs to produce tables. The same rules that apply to a hand-drawn table apply to spreadsheet tables.
Remember that practice makes perfect. Think about how long it took you to master counting up to 10, or even to memorize the 26 letters of the alphabet. You resorted to singing or repeating it again and again.
In scientific investigations, you need to know how to work with units of measurement. The 4 common measurements are volume, temperature, length, and mass.
Cubic meters and liters are often used to measure volume. For example, 1 liter equals 1,000 cubic centimeters.
The 2 common units for temperature measurements are degrees Celsius and degrees Fahrenheit. In Namibia, we use degrees Celsius. Fahrenheit is commonly used in other countries. If you search the web for information, you often find information given in Fahrenheit or other measurements that we do not really use in Namibia. You therefore need to know how to convert between 2 different units. For example, the formula used to convert from degrees Celsius to Fahrenheit is degrees Celsius multiplied by 9 divided by 5 plus 32. And for converting from Fahrenheit to degrees Celsius, we use brackets Fahrenheit minus 32 brackets times 5 divided by 9 is equal to Celsius.
You will usually use milligrams, grams, or kilograms to measure the mass of objects. 1 centimeter is equal to 10 milligrams. 1 gram is equal to 1,000 milligrams. 1 kilogram is equal to 1,000 grams.
When you measure length, you should select the unit of measurement most suitable for the object. For example, you can use millimeters to measure a tiny worm, but meters to measure the length of a crocodile. 10 millimeters equals to 1 centimeter, 100 centimeters equals to 1 meter, and 1,000 meters equals to 1 kilometer.
It is useful to know a few basic measurements and their equivalent values in a bigger or smaller unit, because that can help you convert almost anything or any problem thrown at you. Know your basics. It will make your life easier. Well, time is running out, so let us quickly recap today's important points. Magnification is how many times bigger or smaller your drawing is from the real object. Hand lenses are marked with their magnifying power, for example 8 times or 10 times. A magnification lens makes an object bigger. The formula for calculating magnification is magnification is equal to the size of the drawing divided by the size of the actual object. The final answer must be rounded off to 1 decimal place, and the magnification must be written next to the drawing with a sign times to show magnification. An estimate is a rough calculation of the value, number, quantity, measurement, or extent of something. The best way to record data is in a table. All tables must have columns and rows, and each column or row must have a clear heading. The formula to convert data from degrees Celsius to degrees Fahrenheit is degrees Celsius multiplied by 9 divided by 5 plus 32 is equal to degrees Fahrenheit. To convert from Fahrenheit to degrees Celsius, we use bracket degrees Fahrenheit minus 32 bracket times 5 divided by 9 is equal to degrees Celsius. Cubic meters and liters are used to measure volume. For example, 1 liter is equal to 1000 cubic centimeters. Mass of object conversion units. 1 centimeter is equal to 10 milligrams. 1 gram is equal to 1000 milligrams. 1 kilogram is equal to 1000 grams. The conversion units of length are 10 millimeters are equal to 1 centimeter, 100 centimeters are equal to 1 meter, and 1000 meters are equal to 1 kilometer. Here are your questions for today. 1. Calculate the magnification of a drawing of an ant using the following information. The ant drawing is 88 millimeters in length and the size of the real ant is 10 millimeters long. 2. Convert the following values. 10 centimeters to meters, 10 grams to kilograms, 20 degrees Celsius to degrees Fahrenheit. This is the end of our Grade 9 Life Science series. This program was written by Shiwa Kambata. Keep well and take care.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.